Today we're going to talk about the distance formula, and this really, if you're given two ordered pairs, it's how to find the distance between those. And it's kind of related to really the Pythagorean theorem, because if you're given 2 points, such as this point and this point, the distance between them is going to be really using the Pythagorean theorem, it's going to be the hypotenuse then, isn't it? So that's where this equation comes from, so it's related to that. So the equation we're going to use for distance is equal to the square root of the change in the x-coordinates squared plus the change in the y-coordinates squared. Okay? And again, it doesn't really matter which is your x sub 2 and which is your x sub 1, as long as once you choose, you then use the correct y with that. So find the distance between these two ordered pairs. So our distance is going to be equal to the square root of, we're going to take our x-coordinates and we're going to subtract them. So again, it doesn't really matter which one you start with. So if I want to put negative 4 minus 2, we're going to square that, plus, and since I use the negative 4, I got to use the 6 first, 6 minus 3. Still under the radical. 4 minus negative 2, remember, would be negative 6. So squaring that, I get 36, plus 6 minus 3, sorry, I got my squared up there, is 3. 3 squared is 9. Okay, so add those two together, square root of 45. Usually we're going to write our answers two ways. I didn't put that here, I think I have it on the next slide, but we're going to write it in simplest radical form. So in other words, the square root of 45 is 9 times 5. See my times sign there. So that's really the square root, or 3 times the square root of 5. And then we are going to go ahead and take the square root of 5 and multiply that times 3 to get an approximation. And I believe I asked it around to the nearest hundredth, so 6.71. So you will get kind of two answers for most of these in different forms. And here's where I give you all those directions to follow. Express your answer in simplest radical form, so that means you're still going to have a square root in it, and then as a decimal approximation rounded to the nearest hundredth. So again, we're going to use the formula d equals the square root of, and we look at our x-coordinates. So we're going to be subtracting these two. So 2 times the square root of 3, oops, need my parentheses, minus the square root of 3, that quantity squared, plus, since I use this one first, I need to use a 5 first, minus 3, that quantity squared. So 2 times the square root of 3 minus 3 times, or 1 times the square root of 3 would just be the square root of 3 squared. And then this is 5 minus 3, which would be 2 squared. That's going to give me the square root of 3 squared is 3, plus 2 squared is 4, so I get the square root of 7. Well, that is already simplified, so I don't have to do any simplifying. And then that would be approximately equal to 2.65. You take the square root of 7 on your calculator. Now in this problem, we're given the distance 10 units, but we want to find one of the missing coordinates. So you start it really the same way, except where the d is, you have a 10. So over here, the x's, we can either do a minus 7 or 7 minus a. Probably a little easier for us to do a minus 7, that quantity squared, plus, so I use the a first, I need to use the negative 3 minus 5, that quantity squared. So 10 is equal to, using either the FOIL method or your special pattern, you're going to get a squared, multiply the two together and double it, minus 14a plus 49. This is negative 8 squared would be plus 64. So 10 is equal to the square root of a squared minus 14a plus 113. So now it is a radical equation. Both sides are simplified, so I need to, or the radical is isolated, so I need to square both sides. So I'm going to square this and square this, so I get 100 equals a squared minus 14a plus 113. So I would subtract 100 from each side to get my quadratic equation set equal to 0. I get a squared minus 14a plus 13 equals 0. So how do I solve this? By factoring. Well, I could use other methods, but I think this one's going to factor, so it'll probably be easier to factor it. How about plus 13, and then whoops, sorry, not plus, minus 13 and minus 1. So I get that A equals 13 or 1. And again, remember what we learned, I need to put those back in the equation and try it and make sure that they both work. So don't forget to check your solutions. So if you do put them back in, I will tell you that they do work. So we would get both answers here, but make sure that you do go back and take the time, put it in, 13 squared minus that, and then it ends up being the same thing when you do both of them. So they both work and they're both solutions.